Hello everyone, this is CJ Ong, and today I'm going to give a presentation about software design and constructions. And in the following minutes, I will talk about software design issue and the software construction issues. And the next one is software reuse and examples and its benefits and the software testing principles. So firstly, the software design issues that can lead to delay of the project is data consistency. Just imagine if we have a data and it doesn't store in a database for a very long time. If, example, we lost the data when we are implement our software, and that could lead to a delay in the project. And the next thing we need to think about is the distribution of the components. If we implement a software and we put it into a wrong hardware, or maybe our software doesn't actually communicate well with the certain hardware, and that could actually delay the project. And the third one is security. If our software we design doesn't actually satisfy the security requirement, or maybe it's attacked by the hackers, and we need to have more time and resources to recover our software. And yeah, next one. And regarding to software construction issues, the true problem that I find is lack of communications. Let's say, for example, if we work in a team, if we don't communicate well, and we will delay the project because we don't know which part are we doing, and possibly you have done that part, but I also doing that part, and that will lead to a clash, and communication is really important in my opinion. And the second issues that will affect the project is limited skills capabilities. Let's say, for example, if I don't know how to implement this, I don't know how to create a piece of code, then I will not be able to finish the project on time because I need more time to find the resources online, and yeah, that will cause the delay. So next, software reuse. So software reuse can be described as the process of implementing or updating the software system using the code or program which is existing in the industry or online. So there are two types of software use I find online, which is opportunistic. This one, let's say for example, if I want to implement or executing the software or piece of code, and then I realize that there actually are existing piece of code online, such as Math.net. Let's say for example, when I'm creating metrics, and I find that actually Math.net can help me to design and implement software. Actually, we just need 2 lines of code. And for the planned software reuse, for this type of software reuse, it basically means that, let's say for example, if I'm working in a company, I create a piece of code, and so that in the future I can reuse the code again for the future purposes. The 2 examples of software use is software libraries, as I said earlier, is Math.net, and another example is Selenium. Actually, we just need to download it in the Visual Studio to get the frameworks and libraries. And the other software use example is software patterns. For example, Singleton, Abstract, Concrete Factory, which can actually help us to save our time when we are designing and executing the softwares. And so, by using the software reuse, we can actually increase the software productivity because we don't need that much of time to create the same piece of code, which is actually exists in online. We can just we can just reuse and implement in our software, so we can save our time. And also, less human resources is needed because we don't need that much of people to help in software design. We just need to copy and reuse the code from online to implement the software. So, what are the software testing principles? Actually, there's not 5, it's 7. I have listed all of them. So, the first principle is testing shows presence of defects. So, in this principle, what we do is we need to believe that there's always the defects and errors in the software. So, with this mindset, we will have more eager to find the defects. Actually, this principle can reduce the numbers of defects but not remove all the defects. This is because the software testing talk about the present of the defects. It doesn't talk about the absence of the defects. So yeah. The second principle is early testing. And the test should be planned long before the test begin. This is because it can help us to save our resources, save our time, and so we can get enough time to handle the unknown risks and prevent any delays. And also, if we start very early, we can save our money as well. Because just imagine if we perform the testing at the very end, there will be a whole bunch of code to test, and we are even not sure that if we have enough time to perform the testing. And the third principle is absence of errors fallacies. So in this principle, the software must always fulfill customer requirements. Let's say, for example, if I have implemented 99% of the software and I ensure that the software is 99% bug-free. But what if that 1% is actually not fulfilling the customer requirement? And this will lead to customer dissatisfactions. So this is really important. And the fourth one is Palisade paradox. So for example, so if we repeat the same test case, let's say for example we create for example 100 test cases and we test the software. If we keep repeating performing the testing based on the test cases, we will not find any bugs if we already solved all of them. So we need to review the test case again to find out which one we have not tested yet. And we need to update or maybe add more test cases so we can test the software thoroughly. And the fifth one, exhaustive testing is not possible. So what it means is this type of testing is impractical. It's almost impossible to be tested by human because there are so many inputs. We can't test it with all the possible inputs in such a short time. Especially we have a deadline for the project, and so we might actually can try to perform boundary testing, stuff like that. And testing context is dependency. So testing approach depends on the context of the software we develop. And different types of software need different types of testing. So let's say for example, if I have a e-commerce software, we cannot use the Android software to test it because it actually has different functionalities. So we need different test cases to test a certain software. And the sixth one, the principles, is defects clustering. So this is actually quite famous. It's Pareto principle. To software testing state that 80% of the defects and errors can actually be found in 20% of the code or software. And even if the software, the piece of code is really small, it just takes 20%, you should not ever neglect it because it might actually has some errors in it and it can actually lead to customer dissatisfaction because it doesn't actually fulfill the customer requirement. So make sure that you test the whole software thoroughly. Oops. And the last part is the purpose of the software testing. So after talking about all the principles, why we need to perform the software testing. First one, we need to make sure that the end result meets the customer requirement. That's why we have all the test case, and we also have the meeting with the customer, and so that we get all the requirements that we need and the customer need. And the second one is finding the defect, and this is basically what the software testing does. And thank you.
Thank you.
And this is my referencing.
Thank you.
Well done. Oh, any question?
Any questions?
Any questions? Okay. Go back to your yes. Previous slide. Yes. Testing is context dependent. Can you explain this with an example?
For example, Amazon and the game software. The Amazon will have cart option, will have product details, but games has different functionalities. It doesn't have cart, it doesn't have product details, something like that. So if we want to perform testing, we need test case, right? If we perform the testing, we will not have the same exact test case. And so there will be a different types of testing for both of the scenarios.
Can you give an example? Like what would be different in both of the scenarios, and what would be the two different test case for the same scenario, but since the context is different, the environment is different, right? The platform is different. You would develop two different test case, right?
Yeah.
So can you give a specific example?
So what's the question?
Two different environments, Amazon and Azure,
Yeah.
right? And then you have an application. Okay, and once you are deploying it on Azure and then you are deploying it on Amazon. So of course you will have two different test cases. Not all of them would be different, but only the test cases which are environment dependent or context dependent, only those specific test cases would change, right? So can you give an example, precise one? Or maybe you can talk about two different programming languages. And then
so I just talk about the similar one. Maybe the login will be the similar, but for the context will be different. For example, how they design the UI, and because the UI for both of the software could be different, and so they maybe have different text box as well, and their programming language could be different as well.